Hi, welcome back. Today we're going to be focusing specifically on how energy is transferred when we're looking at a food web or a food chain. So just as reference, last time we did talk about what food webs were. They're just interconnected food chains, and that there are different levels or different trophic levels of the organisms that are found within that food web or food chain. So when we're looking at energy at those specific trophic levels, as you go up the trophic levels, or as you go from primary producer to primary consumer to secondary consumer and on up, organisms within those levels are actually losing energy. Because of this, it limits the number of levels that an ecosystem can have. So last video I said that typically there's no higher than a tertiary or possibly a quaternary consumer within that food chain. And this is why. Because energy, as it moves up those trophic levels, there's actually less energy available in the organisms that those consumers eat. An ecosystem can support more primary consumers than it can tertiary consumers. Why do you think this might be? Well, if we look here, we're looking at this energy pyramid, and it is a diagram that represents the amount of energy lost. The width of the block indicates the amount of energy. So if you look down here, we have the base of our pyramid, and these are all of our producers, okay? So this block is much wider than the one that's above it. The reason is because it's indicating the amount of energy that's available in this level. In the primary producer level, the very first level of the energy pyramid is 100% of the energy. That is all the energy that is made as chemical energy from the sun. And as we go up, the blocks get smaller and smaller and smaller. Okay, so if you look here, this block is only getting 10% of the energy that those organisms eat available in those producers. The reason is because most of the rest of that energy is either not digested or is lost as heat. So those organisms only have 10% of the energy stored in their bodies that can then be transferred on to the next level. Okay, so if you look here, we have 100% at this level. If 10% of the energy moves up, then how much energy is going to be available to this mouse? Hopefully you said 10%. Okay, now the snake is going to eat the mouse. How much energy is that going to get? Well, it's only going to get 10% of 10%. So that is 1% of energy. So when you keep moving up, there's less and less and less energy available. So therefore, these organisms actually have to eat more food because they need to get that energy, which is why it can only support so many organisms within that ecosystem, okay? And there's going to be more producers in an ecosystem, hopefully, than there will be primary consumers. There's going to be more primary consumers than there will be secondary consumers. Because if we have more primary consumers than we do the producers, they will eat all of the food source, and then there will be none left, and they will all end up dying out, okay? And that would be a major problem. So the communities really have to limit the amount of consumers that they have within that ecosystem. Same thing. These snakes, there's not going to be as many snakes or as many secondary consumers as there are going to be primary consumers, because it has to limit how much of those organisms are available, because they have to eat more food than the organisms on the level underneath them, because they're only getting a percentage of that food that's being passed up the energy pyramid. All right. So here is a quick little video that I wanted you to watch, and
all organisms living in an ecosystem, such as the African savanna, require energy and nutrients in order to carry out essential life activities, such as growth, respiration, and reproduction. On the savanna, as in nearly every ecosystem on Earth, sunlight provides the energy that powers life, while nutrients and the other critical building blocks of life, such as carbon, nitrogen, phosphorus, and water, enter the ecosystem from the non-living environment, the atmosphere, and the earth or sea from which the ecosystem arises. Solar energy continuously bombards the Earth, day after day, year after year, providing an essentially limitless source of energy for the Earth's ecosystems. That energy flows through ecosystems, starting with the plants that convert the light energy to chemical energy via photosynthesis. Energy captured by plants is then transferred to the herbivores that graze on the plants. From there, part of the energy is transferred to predators as they eat the herbivores. Scavengers also obtain part of the energy that flooded into the ecosystem as sunlight as they pick at the remains left by predators. Finally, decomposers, breaking down what's left to the molecular level, obtain the last remaining bits of energy from what started as beams of light. It is fortunate for life on Earth that the flow of energy from the sun is essentially limitless, because as energy flows from plant to decomposer, each organism along the way releases part of the energy they capture as heat to the atmosphere, energy that is forever lost for biological purposes within the ecosystem. Thus, for the flow of energy and for the flow of life itself to continue in an ecosystem, an outside source must constantly be injecting it with new energy. Unlike solar energy, the nutrients essential to life are limited. The Earth only has so much carbon or phosphorus or nitrogen available for living organisms. For example, each year, photosynthesis in plants and other organisms captures approximately 1/7 of the carbon available in the atmosphere. If biological processes, such as cellular respiration, didn't return most of this captured carbon back to the atmosphere, life as we know it on Earth would rapidly end, as there would be no carbon in the atmosphere for plants or other photosynthetic organisms to carry out life processes, such as capturing the energy in sunlight. So in order for life on Earth to continue, nutrients must be constantly recycled by the Earth's ecosystems. Thus, energy flows through ecosystems while nutrients cycle through them. The processes by which energy flows through and nutrients are cycled within an ecosystem play a major role in shaping the complex interactions that occur between populations within the Earth's great living communities. Let's now take a look at how the energy and nutrients crucial to life travel through ecosystems and the interactions their travels generate.
So hopefully, I know that was riveting, but I was using that to show how energy moves through an ecosystem and all of the different parts that those organisms within the community can play with each other. Speaking of which, our next unit that we're going to start any day now is going to be looking at really how those different populations within the community have relationships with each other and how that can affect the dynamics of the ecosystem. So this was a short section, but it's really important that you understand the amount of energy that gets passed up for each tertiary level or each energy level on the pyramid. And if you have any questions about that, make sure that you ask in class. Otherwise, I will see you soon.